Demonstrate the first experiment under part A. The question of this experiment is design an astable multivibrator circuit for 3 cases of duty cycle. So the first case is 50%, second case is less than 50%, and the third case is greater than 50%. We need to design an astable multivibrator using 555 timer IC. Also we need to simulate the same thing. The simulation will be explained in the next video. In this video I will just explain how to do the circuit connection for astable multivibrator, and the duty cycle which I will be using here is greater than 50%. I will select the duty cycle greater than 50%. So for this experiment, the components what we need is, the first thing is we need a breadboard. So this is the breadboard which has 4 columns here, the column A and the column 1 and the column 4. So these 2 columns are parallel in connection, which means that we need to connect the pins one below the other. So the middle ones, the column 2 and column 3, so these are series in connection. Here we need to connect the pins one after the other. Okay, so this is the breadboard which we need for this circuit connection. Then we have an IC. So this is an 555 timer IC. So this IC has 8 pins, 4 pins on each side, and there is a mark and a notch at the top. So we need this IC. Also we need 2 resistors for duty cycle. To design an astable multivibrator for duty cycle greater than 50%, we need 2 resistor. One is 6.8 kilo ohm resistor, which is in brown in color, and the other one is 3.3 kilo ohm resistor, which is green in color. And also we need 3 capacitors. So this is the bigger one is the 0.1 microfarad capacitor, and the smaller one is 0.01 microfarad capacitor. So this capacitor has both the capacitor has 2 pins, so there is no polarity. So even the resistors has 2 pins, so there is no polarity even for the resistors. So and we need DC power supply. So here we need to supply the 5 volts power supply to the circuit. So I will be using this DC power supply. So here the blue colored pin is 5 volts and the black colored one is the ground connection. So we need to supply 5 volts as a power supply to the circuit. Next we need an CRO. So this is the CRO which we need to show the output. So this is the screen, and so these are the 2 channels. So there will be 2 channels in the CRO. This is the channel A and the second one is called as a channel B. And we have volts per division for channel A, and also we have volts per division for channel B. And also we have position button where we can set the position for each channel. So this is the position button for channel A and this is the position button for channel B. Also we can move the both the waveform to the right and left by this position button. And another main thing what we have in this CRO is times per division. Here we need to set the frequency for the waveform. So here we need to set the frequency for the waveform. Next, another thing is mode of operation. So here this button should be in dual, okay, which means that I need to get 2 waveforms on the screen. So the mode of operation should be set to dual mode. So these are the things which are considered in the CRO. Now we'll do the connection. So what I will do is I will take up the 555 timer IC, where as I said this IC has 8 pins, 4 pins on each side. So I will fix this IC onto the middle of the breadboard. So like this I will fix this IC. Next, from the circuit we can from the circuit observe that the 8th pin as well as the 4th pin. So these 2 pins should be shorted, 8th and 4th pin, and 2 and 6th pin. 2 and 6th pin should be shorted, and the RA resistor should be connected to the 7th pin. One end of the RA resistor should be connected to the 7th pin. Another end can be connected to the 8th pin or 4th pin, because 8 and 4 are shorted. So we can connect the other pin to the 8th pin or 4th pin. And the second resistor is RB. So here in this circuit design I will be using 3.3 kilo ohm as an RB resistor. One end should be connected to the 7th pin. Another end can be connected to 2 or 6th pin. Another end can be connected to 2 or 6th pin, because 2 and 6 are shorted. Next, coming to the capacitor, this is the main capacitor. The value of this capacitor is 0.1 microfarad. again the capacitor has two ends. One end should be connected to 2 or a 6th pin, another end should be grounded. So coming to the second capacitor, that is C dash, the value of this capacitor is 0.01 microfarad. So the one end of this capacitor should be connected to the 5th pin, another end should be connected to ground, and the output of the 555 timer can be obtained from the 3rd pin. Okay, then we need to use a diode for the duty cycle 50%. To make an circuit, to construct the Astable multivibrator for 50%, we need diode. This diode should be connected across the resistor RB or across the resistor 2, where the positive end of the diode should be connected to the 7th pin, negative end is connected to the 2 or 6th pin. But in this video I am showing the demonstration for duty cycle greater than 75%. So for this we don't need diode. So now what I will do is I will connect the 555 timer IC onto the middle of this breadboard. Next what I will do is I will take up the first resistor, that is RA. The value of this resistor is 6.8 kilo ohm. One end is connected to the 7th pin. So this is the 7th pin here. So this is the 1st pin, 2nd pin, 3rd pin and 4th pin, and from the bottom right corner the pin number starts from 5, 6, 7 and 8. So see here, on the 7th one end of this resistor is connected to the 7th pin, another end is connected to the 8th pin. So this is how I need to connect the first resistor. One end should be connected to the 7th pin, another end is connected to the 8th pin. I will take up the second resistor, that is RB. So one end of the resistor is connected to the 7th pin, another end can be connected to 6th pin, or it can also be connected to the 2nd pin. So what I will do is one end I will connect to the 7th pin, another end I will connect to the 2nd pin. One end is connected to the 6th pin, 7th pin, another end is connected to the 2nd pin. So like this I need to connect these two resistors. RA is a 6.8 kilo ohm. One end of that resistor is connected to 7th pin, another end is connected to 8th pin. RB resistor is a 3.3 kilo ohm. One end is connected to the 7th pin, another end can be connected to 2 or 6th pin. I have connected that to the 2nd pin. Next I will take up the capacitor, that is a 0.1 microfarad capacitor, where this one end should be connected to the 2nd pin or 6th pin. What I will do is I will connect this capacitor to the 6th pin, another end should be connected to ground. So see here I will use the 4th column as a ground connection. So here the 4th column, so it is a parallel connection, which means that the pins should be connected one below the other. So here one end of the capacitor is connected to the 6th pin, another end is connected to the ground. Next I will take up the another capacitor, where one end of this C dash, that is 0.01 microfarad, one end is connected to the 5th pin, another end should be connected to the ground pin. See here, this is parallel connection, that's why I am connecting the pins one below the other. So these two columns, that is the column 2 and 3, so these are series in connection. So I need to consider the pins one after the other. See here, so this is how we need to connect the two resistors as well as the two capacitor. And from the circuit diagram you can see that the pin number 1 is grounded. Now we will make this connection. So I will take up one wire. One end is connected to the 1st pin of 555 timer IC, another end is connected to the ground pin. See here, another end is connected to ground. Next, so from the circuit you can see that 2 and 6 are shorted, which means that I will take one wire. One end will be connected to the 2nd pin, another end is connected to the 6th pin. So I will take up one wire. So one end is connected to the 2nd pin, another end is connected to the 6th pin. Yeah, so we are done with this connection, where what I have done is I have shorted the pin numbers 2 and 6. one end is connected to the second pin, another end is connected to the sixth pin. So we have another connection here, 8 and the fourth pin should be shorted. So what I will do is I will take up one wire, one end should be connected to the 8th pin, another end is connected to the 4th pin. See here, I will take up one wire, one end is connected to the 4th pin of 555 timer IC, this is the 4th pin. So from left, pin number starts from 1, 2, 3, 4. From the bottom right corner, pin number starts with 5, 6, 7 and 8. So here one end of the wire is connected to 4th pin, another end is connected to the 8th pin. Okay. Next, see here on the circuit, so we need to give an plus VCC connection as well as we need to give a ground connection. So for that we will be using DC power supply, 5 volt DC power supply. So this is the 5 volt DC power supply where I have connected one end to the blue colored pins. So another end I should connect this plus VCC to the 8th pin or to the 4th pin, because 8 and 4 are shorted, right? So I can connect the or I can give the power supply either to the 8th pin or to the 4th pin. Now what I will do is I will take one wire, one end is connected to the plus 5 volts of DC power supply, another end is connected to the 4th pin of 555 timer IC. Okay, so then we have a ground connection on this DC power supply. I will take one wire, I will fix one wire to the ground or ground of DC power supply. Another end is connected to the parallel column. So that is column number 4. So this is the ground connection which we have considered in this breadboard, right? So another end is connected to the parallel ground connection on the breadboard. So now we are done with connecting the DC power supply. The next thing is we need to connect the CRO. So see here, channel 1. So here, as I said, there are two channels on this CRO. Channel 1 is the output of 555 timer IC and channel 2 is the output of capacitor. So here the main capacitor is connected between the pin number 2 or 6 and another end is connected to the ground, and the value of the main capacitor is 0.1 microfarad. Now what I will do is I will connect the probe to the channel 1, and the probe has two pins, the positive and the negative pins, the positive and the ground pins. So I will take up one wire, I will connect one end of the wire to the positive probe. Then another end should be connected to the third pin, because the output of an 555 timer is will be obtained from the third pin, right? So one end of that, another end is connected to the third pin to get the output. And I will take up the channel 2 probe. So here also there are two pins. So here also there are two pins. One is positive, another one is negative. So what I will do is I should get the capacitor waveform, right? So one end of the wire is connected to the 6th pin, because the main capacitor is connected to the 6th pin. So one end of the channel 2 is connected to the 6th pin. Okay, so another one is the ground connection. So this is the ground connection. What I will be doing is I will connect this to the breadboard ground connection. So that is column 4. And we have the channel 1 ground. So what I will do is I will again connect this to the channel 2 ground. So from this what I have done is I have connected the channel 1 as well as the channel 2 ground connections to the breadboard, and channel 1 positive, the channel 1 positive is connected to the third pin of 555 timer IC, and the channel 2 positive, the positive wire is connected to the 6th pin. 6th pin where I have connected the capacitor. The main capacitor is connected to the 6th pin. The value of that capacitor is 0.1 microfarad. Now after doing this connection, we need to switch on the DC power supply. So there is a switch in the DC power supply. We need to switch on this DC power supply. So after this, we need to verify the output. So this is the output. There are two waveforms. One, the first waveform, that is which has the T on and T off. So that is the output of a 555 timer IC, and this is the Sawtooth waveform, that is the output of the capacitor. Now I will turn this mode switch to the channel 1. So channel 1, the positive connection of the channel 1 is connected to the 3rd pin of a 555 timer IC. So this is the output of a 555 timer IC. The upper level is called as the T on and the lower level is called as the T off. Now we need to measure the value of T on as well as the T off. So I will be using the position button, and I will bring this waveform, or I will bring this T on to the middle by using the position buttons. See here, the value of the T on is 1.2. So the value of T on is 1.2 seconds, because the waveform has been covered the first cell and 2 divisions on the next cell, 2 divisions on the next cell. So which means that the value of T on is 1.4. So the value of the T on is 1.4. So if I switch off this CRO, see here, this is one cell. One cell has 5 division. The value of each division is 0.2 seconds. Okay, so this is the y-axis and this is the x-axis on the CRO. So here each cell consists of 5 division. The value of one division is equal to 0.2 seconds. The value of one division is equal to 0.2 seconds. If the waveform covered one cell, means the value of the T on or a waveform is 1 second. Then if the waveform covers 2, means the value of the value of that waveform should be taken as 2. So if the waveform has covered 2 divisions on the second cell, means so 0.2 into 7, so that is 1.4. The value should be taken as 1.4. So I will switch on the CRO. Yeah, so align the waveform to the proper position. Now the T on value is 1.4. So like this, what I will do is I need to measure the T off. So I will align this T off to the middle of the CRO scale. Yeah, see here, this T off has been covered. So 1, 2 and 3. So 3 divisions has been covered, which means that we need to multiply 3 into 0.2. So 3 into 0.2 is 0.6. The value of T off is 0.6 and the value of T on is 1.4. So this is how we need to measure the values of T on and T off. So if I change the mode to dual, so see here, I will get the waveform like this. The first channel, the channel 1 is connected to the channel 1, the positive of the channel 1 is connected to the 3rd pin of a 555 timer IC. That's the output of a 555 timer IC. The output of a 555 timer IC has 2 levels. One is a T on, the below one is called as the T off. And the other channel on the CRO is the positive of that channel is connected to the 6th pin, where if I need to get the capacitor waveform, the capacitor waveform will be in Sawtooth. So this the capacitor waveform will be in Sawtooth. So this is how this Sawtooth waveform looks like. So this is the capacitor waveform. So here when during the charging as well as during the discharging time of the capacitor, the 555 timer IC, the output of the 555 timer IC usually looks like this. So the output of the 555 timer IC has 2 levels. One is T on, the upper one is the T on and the below one is the T off. Just we need to calculate the values of T on and T off. So this is the construction for this is the construction for duty cycle greater than 75%. This is the construction of an astable multivibrator for the duty cycle greater than 75%. See here, for the duty cycle that is equal to 50%, what I need to do is I need to take a diode. So diode has the polarity. Again, the diode has two pins. The first pin is called as positive, the another pin is called negative. The positive pin should be connected to the 7th pin and the negative pin should be connected to the second pin or the 6th pin. Okay, the positive end of the diode should be connected to the 7th pin and negative end should be connected to the 2nd or 6th pin. So in that case, so the duty cycle is 50%, right? So what I should do is I need to use the same value resistor. If I take RA is equal to 6.2 kilo ohm or 6.8 kilo ohm, I should take RB is equal to 6.8 kilo ohm. So to construct the astable multivibrator for an 50% duty cycle, both the resistor should have the same value and diode should be connected across the second resistor, that is RB resistor.
So go to search bar, then type electronic workbench. So once after installing, go to search bar of your desktop or of your PC, then type electronic workbench. So here on the search bar, when you type electronic, when you type electronic, so the application will show here. Just click on this, click on this electronic workbench application. Okay, so once you click on this electronic workbench, the application will open like this, and this is the layout. This is the layout of the application, and there are n number of options on the menu bar. Okay, so here see here we have sources, so we can get the ground connection, we can get a VCC connection, so there is a signal generator which we will be using all these components in our experiments. Okay, then coming to the basic part, here you can see a connector, you can see resistors, you can see the capacitors. So we will be using all these things in our experiments. Okay, next coming to the diode part, we will be using the diodes for experiment 1 and experiment number 3. So in that experiments, I will show you how to use the diodes. So here when you click on these diodes, you will get n number of diode options. So first just you need to click on the first diode option. Okay, next transistors, so we don't need transistor. Then coming to the analog ICs, so here for the second experiment we need, for the second and third experiment we need 2 analog ICs, so that is op amp. So here it is a 5-terminal op amp, the second one is called as the 5-terminal op amp. So this 5-terminal op amp which we'll be using in experiment number 2 and 3. Then coming to the mixed ICs, so here you will get, in the last you will get a 555 timer, where I will be using this 555 timer in experiment number 1. Then coming to the last option, so instruments, in this instruments, the third one is called as the CRO, cathode ray oscilloscope. Usually usually in all the analog experiments we can see the output in CRO only. So these are the various options which we have in this application. So now we will construct the first experiment circuit, that is a 555 timer. So coming to the 555, coming to the part A of your analog and digital electronics laboratory. So the experiment number 1 is design an astable multivibrator circuit for 3 cases of duty cycle. The first case is 50%, second case is less than 50%, and the third case is greater than 50%. So in the previous video, I have shown you how to do the circuit connection on the breadboard. So in this video, I will show you how to simulate the same thing on the simulation software. So here, there is a question that simulate the same for any one duty cycle. So to do this simulation, we will consider the circuit. We'll take up the circuit. So this is the circuit of a 555 timer IC. Now we will construct this circuit on the simulation software. So as you can see, what are all the components we need to construct this circuit? So we need one 555 timer, then we need a capacitor C where it is equal to 0.1 microfarad. Then we need another capacitor C dash. So the value of this C dash capacitor is 0.01 microfarad. Then we need two resistors RA and RB. RA value and RB value depends on the duty cycle which we are considering. Then we need a diode. So we need a diode for to construct the circuit for the duty cycle is equal to 50% and less than 50%. For greater than 50%, we don't need a diode. So the diode should be connected across the resistor RB. And we need a VCC here. We will provide a 5 volts VCC plus 5 volts for the VCC. Then we need ground connection. So these are the various components which we need to construct this circuit. Now we'll move on to the simulation software. Now we will construct the same circuit on the simulation software. So before constructing the circuit, first we will place all the components which we need to design this circuit. So the first important component which we need to design this circuit is 555 timer IC. So here you have one option called a mixed ICs. So click on that. The last option is 555 timer. Just drag and drop that 555 timer IC. Okay, so just drag and drop that 555 timer IC. Then we need two resistors. So here on the basic part, we have a resistor. So just drag and drop two resistors. Okay, so then we need two capacitors. So in the basic part only, we will have our capacitors. So just drag and drop these two capacitors. Then what else we need? We need our CRO. So go to instruments. The last option here, the third one is the CRO. So just drag and drop this CRO on the layout. Then what else we need? We need a ground connection. So a single circuit can have n number of ground connection. So here I will take multiple grounds. Then we need one VCC. So here we have one VCC. So go to sources. The second one is VCC. So we need one VCC here, and for that we need one ground. Fine. So these are the various components which we need to construct this circuit, to construct a 555 timer IC circuit or an Astable Multivibrator. So now what I will do is I will rotate this resistors for my convenient. So you can place the components anywhere in the layout. So you can place the component anywhere in the layout, and I will also rotate these the capacitors. Yeah. Then moving on to the circuit. So there are two resistors, right? RA and RB. There are two resistors. Now I will do the circuit connection for the duty cycle that is greater than 50%. So that is a case 2. Moving on to the case 2, to design duty cycle greater than 50%. So let the duty cycle be 75% in this case. And frequency is 1 kilohertz. The time is 1 milliseconds, which and the C is equal to the main capacitor, that is 0.1 microfarad. In this for this case, there are the resistor values of RB is 3.6 kilo ohm, but the standard value which we will be using in our lab is 3.3 kilo ohm. Then RA is the another resistor. The value of RA resistor is 7.2 kilo ohm as per the calculation, but in our lab the standard value which we get is 6.8 kilo ohm, which is approximately equal to 7.2 kilo ohm. So I will be using RB is equal to 3.3 kilo ohm and RA is equal to 6.8 kilo ohm. Now we will set these values on the layout. Yeah. So this is RA. The RA value is 6.8. Just select that RA resistor, right click on that, then go to component properties. Here you need to type 6.8 kilo ohm. Okay, just click on OK. Now the resistor value is a 6.8 kilo ohm. This is the RA resistor. Then the another resistor is RB. Just click on that, select that resistor, and after selecting, right click, then select component properties. In that, the resistance value should be 3.3 kilo ohms. So that's the value, that's the standard value which we are using in our lab. Then moving on to the capacitors. So here the main capacitor C, the value of that capacitor is 0.1 microfarad. So just click on that component properties, capacitor properties. In the capacitance, type 0.1 microfarad and click on OK. Next, go to second capacitor, C dash, select that capacitor, right click, go to component properties. Here you need to type 0.0 microfarad. 0.01 microfarad. 0.01 microfarad, then click on OK. Then yeah, so the VCC part. So the VCC should be 5 volts. Just click on that VCC, right click, then go to component properties and type 5 volts. Click on OK. Next, we will do the connection where I will take up the first resistor. You can see here, we'll move on to the circuit diagram. So see here, the RA resistor is connected between pin number 7 and 8, right? So one end of RA resistor is connected to 7th pin, another end is connected to 8th pin or 4th pin. Here in this circuit, the pin number 8 and 4 are shorted and the pin number 2 and 6 are shorted. So now I will select the RA resistor. One end of this RA resistor is connected to the 7th pin. Another end can be connected to the 8th pin as well as for the 4th pin. Now we will construct the RA. So this is RA. One end is connected to the 7th pin. So this is the 7th pin. Another end, just click on that edge, and another end is connected to the 4th pin. And 8th and 4th are shorted, right? 8th and 4th pin are shorted. So see here. Yeah, see here, 8th and 4th pin are shorted like this, and one end of RA resistor is connected to the 7th pin, another end is connected to the 4th pin. So this is how you need to do the connection. Next, moving on to the second capacitor, that is RB. The value of RB is 3.3 kilo ohm, where one end of RB is connected to the 7th pin, another end can be connected to the 2nd pin or 6th pin. So now we will do this connection where one end is connected to the 2nd pin or 6th pin. So I will connect it to the 2nd pin. Another end is connected to the 7th pin. So this is the wire which comes from the 7th pin. So I will be connecting the other end of the capacitor, other end of the resistor to the 7th pin. And as we discussed, the pin number 2 and 6 are shorted. So this is the first pin from the left part. From the top left part, this is the first pin, then this is 2nd pin, 3rd and 4th, and from the bottom right corner, the pin number starts from 5, 6, 7 and 8. So as we discussed, pin number 6 and 2 are shorted, right? So I will connect a wire from the 6th pin to the 2nd pin. So this is the wire which comes from the 2nd pin. So here from this, you can see that pin number 6 and 2nd pin is shorted. So we are done with the resistor connection. Then we are left out with the capacitor connection. The main capacitor we are using in this circuit is C and C dash, where C value is 0.1 microfarad and C dash is 0.01 microfarad. So coming to the first, coming to the construction of a C, the value of C is 0.1 microfarad, where one end of this capacitor is connected to second pin, which means that 2 and 6 are shorted, right? So one end of the capacitor can be connected to either second pin or sixth pin. Another end should be grounded like this. Now we will do this connection. So go to electronic workbench, where one end is connected to the second pin, or so this is a wire which comes from second pin. So one end is connected like this, another end is connected to the ground. So this is how you need to do the connection. Moving on to the second capacitor, that is C dash. One end is connected to the fifth pin, another end is connected to the ground. The value of C dash is 0.01 microfarad. So here, this is 0.01 microfarad, where one end is connected to the fifth pin from the bottom right corner of the IC-555. So this is our fifth pin. Another end should be grounded. Yeah. So we are done with connecting the capacitors. Next, when you see the circuit, pin number 1. So the first pin is grounded. So the first pin is directly grounded. So we will do this connection now. So this is the first pin. So I will connect this first pin to ground component. Okay. Next, we are done with all the pins. Next, coming to the VCC. See here, VCC is plus 5 volts, and positive end of this VCC is connected to the 8th pin or 4th pin. So you can choose 8th pin or 4th pin, because 8 and 4 are shorted together. So we can connect the positive plus 5 volts to the 8th pin or 4th pin. So this is the plus 5 volts VCC, where positive end is connected to the 8th pin or 4th pin. So I will connect the positive end to the 8th pin. Okay, so I will connect the positive end to the yeah. So this is how we need to connect the positive end to the 4th pin or 8th pin. So here I have connected the positive end to the 8th pin. So 8 and 4 are shorted. So just I have connected that positive end to the shorted end. And the negative should be grounded. So the negative or the minus 5 volts should be grounded like this. Okay, next, the last part is connecting the CRO. So when coming to the CRO, so this is the CRO which we have in this electronics workbench software. So on the below you have 2 points. The first point is channel 1 positive, second point is channel 2 positive. Moving on to the right part of the CRO, again you will be having 2 points. The first point is channel 1 ground. The second point on the right hand side is channel 2 ground. So both should be connected to ground like this. The right part, the 2 pins which you can see on the right part, so both should be connected to ground. Now to get the output, so just see the circuit. The output is obtained from the third pin, right? From the third pin, the output is the 555 timer output is obtained from the third pin. So what I will do is from the third pin, I will connect this to positive. Okay, so what I have done is from the third pin, I have connected a wire to the channel 1 positive. Next, we need to get a capacitor waveform, right? So channel 2 positive, the second point on the below of the CRO. So on the below, there is a second point. So what I will do is I will connect this second point to the capacitor. Why means, yeah. So the capacitor, one end of what I have done is, so there are two channels on the CRO. Channel 1 positive is connected to the third pin. Channel 2 positive is connected to the capacitor, that is 0.1 microfarad. To get the capacitor waveform on the channel 2 of the CRO, we need to do this connection. And to get the 555 timer Astable Multivibrator waveform, we need to connect channel 1 positive of the CRO to the output of a 555 timer. The output of 555 timer is from the third pin. Now we are done with the connection. The left out part is we need to see the output. So just double click on this CRO, cathode ray oscilloscope, and when you double click on this, so there is an on and off button. So just switch on the CRO here. Yes. Switch off the CRO, and this is the waveform which you need to get for 555 timer IC. See here, there are two waveforms. When you observe these two waveform, one, the first waveform is in the square, the first waveform is in the square shape. So that's the output of a 555 timer IC. That's the output of a 555 timer IC. And T on is more and the T off is less. The upper part is the T on and the lower part is the T off. For 75% duty cycle, T on should be more and T off should be less. So that's what we got in this waveform. Okay, so here when you observe the waveform, T on is more and T off is less. And there is another waveform, that is the Sawtooth waveform, where this is the Sawtooth waveform which we got from the capacitor. The CRO has two channels, right? So channel 1 positive is connected to the output of the 555 timer IC, that is to the third pin. Another channel, the channel 2 positive, is connected to the capacitor to get the capacitor waveform. The capacitor waveform, when you observe in this circuit, the capacitor waveform is in the form of sawtooth. So this is how we need to get the waveform. This is how we need to get the waveform for 555 timer IC for the duty cycle greater than 50%. Here I have constructed the circuit for 75% duty cycle. Next, suppose if you want to construct for the duty cycle equal to 50%, then you need to consider the diode. So here, so go to diodes, select the first diode. Okay, so here you will be having two terminals on the diode. So the two terminals, the first terminal is the positive terminal. One terminal is called as the positive terminal. Another end is called as the negative terminal. Where this diode should be connected across the resistor RB. See here, according to the circuit, so if we are constructing a circuit for equal to 50% and less than 50%, we need to connect a diode. So the diode positive end is connected to the RB, the one end of the RB, that is connected to the 7th pin, which means that the positive end of the diode should be connected to the 7th pin of a 555 timer IC, and negative is connected to the 2nd pin or 6th pin to get the waveform. So in the question, they have asked us to demonstrate the simulation for one duty cycle. So this is the demonstration for duty cycle that is greater than 50%. So to construct the circuit for the duty cycle greater than 50%, we don't need diodes. To construct the circuit for the duty cycle equal to 50% and less than 50%, we need diode. So that diode should be connected across the resistor RB, which means that positive end should be connected to the seventh pin. Negative end of the diode can be connected to the second pin or sixth pin, because 2 and 6 are shorted, right? So one other end, the negative end of the diode, can be connected to either second pin or sixth pin. So this is the simulation of Astable multivibrator by using a 555 timer IC.